Hello and welcome. In this video, we're going to talk about what to expect from your data science course. Quite possible that you've already done a course. You may see this as a checklist. Are you equipped with everything that we're going to discuss here? Because this is what most of the courses teach you. And if you're considering doing a course, then the good news for you is that we've already done a detailed benchmarking. We're going to talk about what does a typical data science course teach you. You can always tally if your course actually covers the things that we are talking about here. Let's get started. Since data science is a diverse field, you get people from different backgrounds. So there would always be certain foundation modules in any data science course. These modules are there to ensure that everybody who begins the data science journey is on the same page. What all is covered in these modules typically? Let's have a look at it. I'll probably scroll down to give you a clear view. So there would always be a module around introduction to Python. There are other programming languages and other tools that also exist, but Python right now is the most popular language. So every good course would definitely talk about an introduction to Python kind of module. And what all would this module contain? It would contain basic knowledge of different data types, what kind of data is there, because you're learning data science. It all starts by first knowing about the kind of data that you have. It's a numerical data or a categorical data. It'll also talk about working with conditionals and loops, etc. So I'm just calling in general as control flow, and at least to the extent of being able to write functions so that you can accomplish what you want to do with the data will be taught to you. Next is when you read a data, typically a structured data, which is something like a spreadsheet, you need to be able to work with it. So they will always teach you something about how to work with the data frames. That's the name of the structured data. Python is well equipped with many libraries that enable you to do your work with a lot of ease. One such library is pandas, which allows you to work conveniently with data frames. Similarly, there's a library called numerical Python or NumPy, which helps you work and manipulate data in different ways. The next leg would be data visualization. So when you have data available, it is not possible to look at the entire data at once or remember the entire data at once. What you want is a nice summarization. And that summarization could also be in the form of tables, but tables still are inconvenient. Plots are a little more user-friendly. So they definitely teach you about basic libraries in Python like matplotlib and Seaborn, which allow you to do convenient data visualization. Moving on, as a part of the foundation itself, there would be a module related to statistics. This might bring certain topics that you already are very comfortable with, like you may be very well versed with the central tendencies like mean, median, mode, standard deviation range, interquartile range, and other stuff. They'll also be teaching you about the concept of probability and distributions. Like I said, people come from diverse backgrounds, so not everybody might have studied this. So most of these courses would cover these topics from scratch. They'll teach you about computing probabilities and how those are meaningful, and they'll also teach you about some basic distributions. Then comes a little interesting topic, which is more diagnostic in nature. This is known as hypothesis testing. This is a very powerful topic. It comes under inferential statistics. So you're studying a sample and trying to make conclusions about the population. It is very important that you understand that when you're working with data, it may not always be residing locally on your machine. So most of these courses would always talk about some kind of a database. At least SQL would be discussed, structured query language. This enables you to be able to fetch data from databases. This covers the foundation piece. So moving on, now before I go to this section, I just want to give a disclaimer. There are times when you will see a program which says machine learning specialization. That will also have these kind of topics. So there's a fair bit of an overlap between data science and machine learning. You should not get confused. So what I'm talking about could be also called unsupervised learning or unsupervised machine learning. What is it? So when you have data, you're trying to explore patterns in the data. And in two broad categories, you can put this. First is dimension reduction. It is something to do with the columns in the data. Imagine a spreadsheet, it has columns, it has rows, right? So when you're dealing with reduction of columns, because there may be a lot of information that's provided to you, some of this may not be useful or may be redundant. This is the first category, which can further be divided into subcategories. So one thing that I've done here is I've given some color coding because not all the courses cover everything. So PCA or principal component analysis is something which is commonly taught in all the courses, but something that's known as TSNE or T distributed stochastic neighbor embedding, a beautiful visualization technique, is not necessarily covered in all the courses. So similarly, there is exploratory factor analysis, which is not necessarily covered in all the courses, but falls under the same tenet. Some courses do, some don't. You may want to check for these if your course has this or not. The next category that we have is the segmentation or the cluster analysis. This talks about the similarity between the rows. In this, you further would see certain common techniques which are taught, like k-means clustering and hierarchical clustering, very powerful techniques. But there are certain extended techniques which are very useful, taught in very few courses, like k-medoids clustering and Gaussian mixture models. So these are extended pieces, not covered in many courses. At least these pieces are covered in most of the courses. Moving on, the backbone of any data science course would be supervised learning. This is where you start doing predictions. This is why data science is so popular today. So what do we learn under supervised learning? Let's see this. There are models that you begin to create here. So given certain inputs, you're trying to predict the outputs here. The classic statistical models that you're taught here in this section, these could be linear regression models, logistic regression models. Linear regression can further be extended into two categories, which is actually not covered in many courses. So I've put it in green here. That's ridge regression and lasso regression. Lasso is again a very powerful regression technique. And there are some extended topics within the statistical models like linear discriminant analysis and polynomial regression. These may not be covered in most of the courses, but linear discriminant analysis at least is very powerful. You may want to learn about it. Polynomial regression actually improves the performance of typical linear models. This is again an important topic, but it's covered in a few courses, in others it is not. Then within supervised learning, moving on to the other category of models, apart from these statistical models, we also have tree-based models. What are these? They teach you about decision trees. These are very user-friendly, require very less effort, very less data preparation, and give you amazing results. Within the same sequence, you have something that's known as bagging. There is random forest, which is more than just a tree. There are multiple trees here. And there's something called as boosting, which has many subcategories. This is one algorithm which is very, very popular in all the competitions. A lot of hackathons and competitions that happen for huge prize money, most of the times people would be found using some of the boosting techniques. So common boosting techniques that are covered in most of the courses are these: adaptive and gradient boosting. The one that's relatively less found is extreme gradient boosting, which is very powerful again. Then we have the models based on the probabilities, like the naive Bayes model. So if you study probabilities, you'll be learning something that's known as the Bayes theorem. This is an extension of the Bayes theorem with an assumption. That's why it's called naive Bayes. Then we have a very good non-parametric model, very, very relatable common sense model, which is known as the K nearest neighbor model. It does not necessarily give you an equation to work with, but it makes its decisions in a very intuitive way. Then again, a very powerful model that's known as the support vector machines. These are the strongest models that competed with the neural networks in their early days. So this is a very, very good model that you may want to learn about and should be there as a part of your course. Then moving on, we have something that's known as the foundations of artificial neural network. So in general, you should not expect too much on the deep learning or neural network side from a data science course. They give you some foundation related to it, because the moment you start talking about complex neural networks, it would become an artificial intelligence course. It would not remain a data science course, typical data science course. That's the fine boundary. The data science course would typically talk about working with the structured data and to some extent basics of unstructured data, like the data which is not arranged in rows and columns. But an AI course would primarily talk about working with the unstructured data, like images, videos, text, audio. So data science course would only give you a foundation related to artificial neural networks. They may give you an introduction to natural language processing and computer vision, but that will be very, very basic. So this was about the supervised learning piece. And there are additional modules in most of these courses. Scroll it up. So additional modules would typically involve a specialized tool for data visualization. We did talk about data visualization using Python as well, but Python is not essentially a tool which is only known for visualization. It does a lot more than. So there are tools which are specialized in data visualizations, and one of these would definitely be covered in a good course. That would be either Tableau or Power BI. I'm not saying these are the only options, but these are the most popular options at the moment. Apart from these sections that we just talked about, It is good to know the conventional time series forecasting as well, and that will be a part of most of the courses. So time series forecasting has a basic assumption that the data that you're collecting is time sequenced. Not all the data is always time sequenced. This has very different classic models, but this is an interesting area to learn about. And very few courses would actually cover something which is the last leg, which is the model deployment. So you learn how to create various models in any data science course. In fact, about 80% of the time in a data science course would be allocated to supervised learning, creating different types of models. But how do you bring it to production? This is something which is a slightly different skill set and maybe a bit of a stretch at times. Very few courses actually cover it. So this is it. Just wanted to give you a high-level overview of what does a data science course look like so that you can make a better and informed decision. And you may see this as a checklist for yourself whenever you have to quickly go through revisiting these topics that you might have learned somewhere.